Hi, good morning everyone. Today I want to share with you how to do the operations on discrete signals. Okay, there are a few operations such as the additions, multiplication, and other operations such as the time shifting or time folding. Okay, in order to do the time shifting, okay, there is a plus and minus the operation. Okay, let's say if you have the yn equal to x n minus beta, so this minus here means that it's a delay. Okay, so how to do the delay? If you use the origin method, means that you shift the origin. What do you mean by shift the origin? There is a marker of the origin. So you shift the marker of the origin to the left by beta unit. Let's say if the question with plus, so this plus means it's at once. Okay, so you shift the origin to the right by beta unit. Okay, then what about the folding, time folding? So time folding, the symbol is negative. Okay, so yn is equal to x negative n. So this is the folded version or the mirror image of the xn at n equal to 0. Okay, so let's say I have the question like x negative n negative beta. What should you do? Okay, so you have two methods here. Either you shift, do the shifting first, then fold, or you do the time folding first, then time shifting. Both also can, but it's slightly different. Okay, if you do the time shift first, you straight away like x negative n negative beta, right? So you, for the shifting, so you choose x n minus beta. So you, for minus is what? Delay, right? So you shift the origin to the left, beta unit, because it's the negative. Then fold. Okay, fold is negative, this negative. So you fold the n minus beta. So you, what you will get is x negative n negative beta. Let's say if you choose to do the time folding first, so you x negative n. Okay, x negative n. If you do a folding first, this means you fold the xn. So you get x negative n. And then do the time shifting. So bear in mind that if you do the folding first, then you do the time shifting. This time shifting, make sure that you factorize it. Let's say just now it's negative n negative beta. So you, after you have done the folding, then followed by shifting. So this shifting you must factorize it. So now you have in the bracket is n plus beta. So if you multiply in the negative, you will get negative n negative beta, right? So you need to factorize it. So the shifting here is not n minus beta, is n plus beta. All right. Okay, let's look at the some example. Given the xn is equal to 2, 3, 4, 5, 6, 7, find and sketch. So if you look at this question, do you know where is the origin? Yes, it is at 4. The origin is at 4 because of the marker here. Okay, let's look at the question one by one. Okay, if you look at here is 2, 3, 4, 5, 6, 7, right? This is the xn. So if you sketch the graph, it will be look like this. 4, 2, 3, 4. So 4 is at the n equals 0. 5, 6, 7. So all this is the amplitude. Okay, and show that this marker show that where is the origin? The origin at 4. Okay, now the question is x n minus 3. Just now I told you if minus, that one is a delay. So if you use the origin method, this means that you will need to shift the origin 3 unit to the left. Okay, 3 unit to the left. So just now is 4. Right, the origin is at 4. So 3 unit to the left, 1, 2, 3. So your yn will be 0, 2, 3, 4, 5, 6, 7. Why is 0? 0 means that After this, all the value are 0. So now you don't have the value at here, so you just simply put a 0. Okay. Next question is fn equal to x n plus 2. So plus 2 means that is the at once 2 units. So you shift the origin 2 units to the right. So originally is at 4. So you shift 2 units to the right is 6. Okay. And then you have another question is hash n equal to x negative 1 plus 1. Okay, now you do the shifting first. So for the shifting, so for the easiest one is you do the shifting then folding is easiest one. You don't need to factorize it. Okay. Okay, so x n plus 1. So n plus 1 means that you at once 1 unit to the right. So you get origin at number 5 at the value of 5. And then folding. So folding means that it's a mirror image. You fold everything. So 7 will be at the from the right hand side. You will transfer to the left hand side. 6 also transfer to the left hand side. But origin still remain the same. And 4 is at the left hand side. You transfer is to the right hand side. 3 and 2 also the same. Okay, you have any question? Okay. After you have done the after you have learned the operation on the discrete signal, okay, just now I show you a few examples. So I believe that there's no problem for you to solve the exercise 1.2. Okay, you solve the question exercise 1.2. And also this question. Next, we will go to the another new subtopic that is the symmetry. So there are two types of the symmetry. Either is a even symmetry or an odd symmetric signals. Okay, what is even symmetric signals? So if the signal xn is identical to its mirror image x minus n, is called even symmetric. Okay, even symmetric left side and right side is the same. Okay, and symmetric at y equal 0. Okay, at the y axis. So what is odd symmetric? Odd symmetric is if x n differ from the mirror image x minus n only inside. So it's called an odd symmetric or anti-symmetric. Now let's look at the graph. Then you can have a better understanding. Okay, this is x even. Okay, x even n is equal to x even negative n. So left hand side and the right hand side is the same. Okay, you get the same value. And it's a mirror image at the y-axis. So this is so-called the even signal. Left side and right side are the same. But what about the odd signal? Okay, if you look at here, x odd n is equal to negative x odd negative n. This means that it's the 2 times of the mirror image. First one, if you have the xn is these 2, and then the mirror image at the y-axis, you will get the signal here, okay, here and here. And you have the second mirror image at the x-axis, that what is you get from here, okay. 2 times of the mirror image. First is the y-axis and second one is the x-axis. And the equation is equivalent to x negative x naught negative n. Okay, first of all is a negative x negative n you get here, and then you get negative x is this side, so it's a odd. Okay, so this is so-called the odd signal. So it's worth to take note that the odd symmetric signal x0 x odd 0 means that at the t equals 0 or at the origin the value is 0. Okay, because of what? It's from the summation from negative beta to beta. You sum up everything, so it's actually is cancelled out. Then you will get the value of 0. So x odd at t equals 0 is 0. Okay, even and odd parts of the signals. Even symmetric and odd symmetric are mutually exclusive. This means that they cannot occur at the same time. So any signal xn may be expressed as the sum of the x even and x odd. So this means that you have the signal of xn. So this signal of xn actually is a summation of x even and x odd. Okay, so this is the formula that you need to remember. Sn equal to x even plus x odd. Okay, so to find the x even and x odd from the xn, Sn is folded and invoked symmetric to get x minus n. Okay, x minus n, so equal to x even negative n plus x odd negative n equal to x even n minus x odd n. Okay. So I assume that this xn is A and x minus n is B. So later I will do the adding equation and subtraction of equation to this. Okay, because later we need to come up with the x even equation and x odd equation. Okay, so you have the xn and x negative n here. Now we add the A and B. So A and B is 2x even plus xn plus x minus n. Okay, if you refer to this one, so Sm plus with x minus n. So as you know just now, the xn is equal to x negative n for the even, right? For the even signals. So see, x even is equal to x even n is equal to x even negative n. So it's the same. So that's why here you will get 2x even n. And then x even n plus with x even negative n here. So in order to, here you have 2x even n. Now you want to get the x even only. So you divide by everything here, divide by 2. So you get 0.5 xn plus 0.5 x negative n. So actually this is how you get the x even signal, x even n. So this is the formula that you need to remember, because most of the time we will use this formula to find the answer to solve the problems. Okay, so what will happen if we subtract the equation of A and B here? Now we have the 2x even n. Okay, just now is this one, right? So x n, okay, xn minus with xn minus with x minus n. So you have the xn minus x minus n. So as you know just now, x odd equal to negative x odd negative n. So now you subtract, right? You subtract this one minus with this one. So minus minus you get positive. So you will get 2x odd n equal to xn minus x minus n. So in order to get the x odd n only, so you divide by everything at the right hand side, you will divide by 2. So you will get 0.5 xn minus 0.5 x minus n. Bear in mind that if xn has the even symmetric, x odd n will be equal to 0. If xn has the odd symmetric, x even n will equal to 0. So this is the properties of the xn for the even. Okay, well, you have even symmetric, s odd, you get a 0. For if you have the Sn is odd symmetric, x even will equal 0. So this is a property that you can use. Next, we go through another example. We go through an example on the even and odd signals. Let's say a given signal xn is 4, negative 2, 4, negative 6, and calculate the even and odd parts. Okay. To cover the symmetric limits, you see that from the question is 4, 0, 2, 4, negative 6. So if you see here, the left hand side only 2 units and the right hand side only have 1 unit. It based on the question, right? 4, negative 2, only 2 value. Now here at the right hand side only 1 value. So you need to have the same equal units. So you 0 pads the right hand side. So 0 pad the signal. So I just 0 pad the value is 0 because you don't have any value. So you put a 0 just to cover the symmetry limits. Okay. Now if just now is based on the question x even. Okay. Review back, the x even is 0.5 xn plus 0.5 x minus n. This means that you need to find the 0.5 xn. What is the value of 0.5 xn? And what is the value of negative 0.5 x negative n? Okay, now here I provide you the 0.5 xn is what? Based on the xn, and you get what is the value for 0.5 xn. So here is 4, negative 2, 4, negative 6. So half of this value is 2, negative 1, 2, negative 3, and 0. Okay, once you get this one, and then you need another value is x negative n. So again, it's a folded version of this one, 0.5 xn. So folded version is x negative n. So you use the same value, just that you mirror image. So you move the right hand side value to the left and left hand side value to the right. Okay, so you move the negative 3 and 0 to the left hand side and 2 and negative 1 to the right hand side. And now you transfer all the information to the table. So now you know that here is origin. So left hand side you have 2 units, so means that n equal to 2. So this is negative 2, negative 1, 0, 1, and 2. So you put a n first. You identify where is the origin. Okay. So xn, you put the xn into the columns. Okay, and row. And x minus n is this one. Okay, here you have 0, negative 6, 4, negative 2, 4. Okay, and then you fill in the 0.5 xn from 2, negative 1, 2, negative 3, 0. Okay, and also negative n xn. You fill in here. Okay, so you still remember the x even is what? X even is 0.5 xn plus 0.5 x negative n. For the odd is minus. For the odd is minus. So if you look at here, in order to get the x even, you need to sum the blue color. Okay, sum up the blue color. So you have 2, you sum this up, you get negative 4. You sum this up, you get 4. You sum this up, you get negative 4. You sum this one, you get 2. Okay, so this is x even. What about x odd? Okay, x odd is minus, right? So 2 minus 0, you get 0. Negative 1 minus with minus 3, so you get 2. 2 minus 2, you get 0. Negative 1 minus minus 1, you get negative 2. Then 0 minus 2, you get negative 2. So this is how you get the x even and x odd. So in order to check the answer, you can plot the graph of x even and x odd. Okay, now I have plot the x even signal with 2, negative 4, 4, negative 2, and 2. Okay, you plot it here, 2, negative 4, positive 4, negative 4, and 2. So when you plot it, can you see that the left-hand side signal and the right-hand side signal are identical? Yes or no? If yes, right hand side and the left hand side signal are the same and they are the even signal. Okay, next we look at the odd signal. Okay, we plot 2, 2, 0, negative 2, negative 2. Okay, after you plot, what can you see? What can you see here? Okay, you can find that the left hand side signal is asymmetric with the right hand side. So this is because it's a odd symmetric. Okay. Okay, if you not believe, maybe you can try mirror, 2 times of mirror image. First mirror image at the y-axis, so you will get here, and then mirror image at the x-axis, you get here. So it's correct. Okay, so this kind of characteristic, you can check the answer after you do the calculation. You can check the answer whether you get the correct answer or not.